In 1977, two quiet travelers were launched into the heavens with a mission so modest that today almost feels music unbelievable. 5 years of exploration, close encounters with Jupiter and Saturn, and then silence. That was the expectation. No one believed these machines would ever reach the boundary of the solar system. Music, much less pass beyond it into interstellar space. But a rare alignment of the planets opened a narrow window in the cosmos, giving Voyager 1 the chance to slingshot music from planet to planet, accelerating far beyond what anyone had predicted. Along its path, it exposed violent storms, music larger than Earth itself. It uncovered oceans concealed beneath frozen crusts. It revealed worlds that appeared calm, yet were anything music but, and eventually it reached a sharp and invisible frontier where the sun's influence suddenly ends. Armed with technology weaker than a household light bulb and memory smaller than a modern notification sound, Voyager 1 continued onward, crossing a threshold no human-made object had crossed before, and began listening to something music never heard. What it found was not simply distance, but pressure, structure, sound, and limits. And that discovery would quietly redefine music where our world truly ends. Voyager 1 was never intended to become a deep space pioneer. When it launched in 1977 alongside Voyager 2, its purpose was straightforward and finite: travel to Jupiter and Saturn, examine them music closely, and then fade into the background of history. The only reason such an ambitious route was possible was a rare planetary alignment occurring roughly once every 175 years, placing Jupiter, Saturn, Uranus, and Neptune along the same side of the Sun. That alignment allowed the spacecraft to use each planet's gravity as a sling, leaping from one world to the next in what NASA called the Grand Tour. Even the launch hinted that something unusual was unfolding. Voyager 2 lifted off first, yet just 16 days later, Voyager 1 departed on a faster path and soon overtook its twin. Only 13 days after launch, from more than 11 million kilometers away, it turned back and captured something never seen before: Earth and the Moon together from deep space. A distant music family portrait, with our planet reduced to a tiny blue dot suspended in endless darkness. Even then, the mission was already stretching past its original design, transforming technical objectives into moments that force humanity to see itself from the outside. When Voyager 1 reached Jupiter in early 1979, it did more than observe a planet. It dismantled decades of assumptions in just days. What had appeared from Earth as a distant music gas giant revealed itself as a violent and intricate world, wrapped in massive storms and surrounded by moons behaving like a miniature solar system of their own. It uncovered thin rings no one knew existed, and new moons later named Phoebe and Adrastea, transforming Jupiter from a familiar sphere into an active and evolving system. The Great Red Spot, long visible through telescopes, was finally seen up close, confirmed as a colossal storm spinning counterclockwise, larger than Earth itself, a centuries-old atmospheric giant raging across the planet's surface. But the greatest shock came from Io. Voyager 1 detected active volcanoes erupting there, the first time such activity had ever been observed beyond Earth. Io was not frozen or lifeless. It was violently alive and remains the most geologically active world in the solar system. Then there was Europa. Its smooth, fractured ice hinted at something even more extraordinary beneath the surface. Voyager's images suggested a vast, subsurface ocean hidden under kilometers of ice, quietly introducing the idea That one of the most promising places to search for life might not be a planet at all, but a moon orbiting a distant giant. After Jupiter, gravity itself became a tool. Voyager 1 accelerated toward Saturn, arriving in 1980 with more momentum than any spacecraft before it. What once seemed elegant and simple revealed unexpected complexity. Saturn's rings, which had appeared as a single thin band, unfolded into hundreds, even thousands of delicate and dynamic structures. Voyager 1 also discovered new moons, including 1’s, whose massive Herschel crater gave it the appearance of a misplaced Death Star drifting through space. Yet the most critical encounter was with Titan, Saturn's largest moon and the only one in the solar system with a dense atmosphere. Though its surface remained hidden, analysis revealed methane existing there, the way water behaves on Earth, as a solid, liquid, and gas. That discovery opened the possibility of lakes and rivers far from the sun, reshaping ideas about chemistry and habitability. But the close flyby of Titan came at a cost. Saturn's gravity bent Voyager 1's path sharply out of the solar system's plane, ending forever its role as a planetary explorer. From that moment, it was no longer visiting worlds. It was heading toward a boundary. On August 25, 2012, Voyager 1 reached that boundary. Its instruments recorded a sudden drop in solar particles and a sharp rise in high-energy galactic cosmic rays. It had crossed the Heliosphere, the frontier where the solar wind ends and true interstellar space begins. Scientists had expected a slow transition, a gradual fading of the sun's influence. Instead, the change was abrupt, as if the spacecraft had struck an invisible wall. Beyond that boundary, space was not empty or silent. Voyager recorded a persistent hum around 3 kilohertz, interpreted as interstellar plasma waves, allowing scientists to measure the density of the space between stars. It also revealed that the interstellar magnetic field was far stronger than expected, compressing the heliosphere and proving that our solar system exists inside a tightly shaped bubble within a region known as the local bubble, a vast cavity carved by ancient supernovae. By the time Voyager 1 was tens of billions of kilometers away, everything about it should have failed. Its computers carried less than 70 kilobytes of memory. Its transmitter operated at just 22.4 watts. Power came from slowly fading radioisotope generators fueled by plutonium-238. Engineers shut down instruments one by one to conserve energy, and still it continued. It carried the Voyager Golden Record, a disk filled with images of Earth, greetings in 55 languages, music, and the sounds of life, a quiet message to the cosmos. Then, on November 14, 2023, Voyager 1 fell silent, sending back meaningless binary noise. Engineers traced the failure to damaged memory within its flight data system. Rather than give up, NASA attempted something audacious, rewriting and relocating decades-old code into healthy memory sections. Each command required 22.5 hours to arrive and another 22.5 to return. Days passed in silence. On April 20th, 2024, Voyager 1 responded. Its voice, faint but clear, returned. Months earlier, Voyager 2 had survived its own crisis when its antenna drifted just 2 degrees off Earth before being realigned. These moments revealed the truth. The Voyagers were aging explorers, fragile yet persistent, still answering long after their designers expected them to fail. Voyager 1 never collided with a physical object in deep space. It crossed a boundary more profound than any wall. It found pressure where we expected, freedom, structure where we imagined, void, and a steady hum where we assumed. Silence. It proved that even beyond the sun's reach, space is active and alive. As it continues toward the distant or cloud, a journey that will take thousands of years to complete, it carries more than instruments. It carries us, our voices, our music, our images, and the quiet statement that we were here, that we wondered, and that we reached beyond our limits. Whether anyone ever discovers that message may not matter. What matters is that we sent it. Long after its final signal fades, Voyager 1 will keep traveling, a small fragment of humanity, moving through the dark on our behalf. And perhaps that is the most remarkable encounter of all, the realization that, in the vastness of deep space, we are not merely observers of the universe, but participants within it. If this journey reshaped the way you see the cosmos, share your thoughts below. And if you want to keep exploring the edge of what we know, don't forget to like, subscribe, and follow the story of the farthest travelers humanity has ever created. I'd love to hear what you think about this, so drop a comment below. If you enjoyed our conversation today, please share this video and subscribe to help the channel grow. Every bit of support counts.